Please welcome to the stage virtually, Carly Anderson.
My name is Carly Anderson. I'm a chemical engineer and partner at Prime Movers Lab. We're a venture capital firm that invests in breakthrough science startups with the potential to impact billions of lives. So what that means to us, just to give everybody a little bit of a flavor, we invest in early stage companies across 6 verticals. That's energy, agriculture, infrastructure, manufacturing, transportation, and human health span, essentially the building blocks of civilization. We don't invest in pure software. Over the past 20 years, we got Facebook instead of fusion and flying cars, and we believe it's time we put our resources and brain power towards moving humanity forward. We also firmly believe that the next group of category-defining companies are going to be in this breakthrough science, deep tech, frontier tech, whatever you want to call it, this space. So with that, here are just a couple examples of what we funded in the past. Our firm has made investments in 2 fusion companies. That's Commonwealth Fusion Systems and Focused Energy, which is a laser-driven fusion company. Because like I think many of the speakers today, we in my firm believe that fusion is something the world needs, both to meet the challenges of climate change, to meet growing energy demand, to lift people out of poverty or energy poverty, and to ensure energy security. So as you can probably tell from that introduction, I am not a LENR expert. I am very grateful to the ICCF team for holding this event, bringing together all of us and educating the broader community. And I am going to share my perspective on funding moonshots more broadly and best practices from other areas. So just to give a quick overview of what I'm going to talk about, what is a successful moonshot? How are they funded? What are some tips for raising private capital? And one investor data point, so my opinion on low energy nuclear reaction potential in this space. I'll also just briefly say that the primary audience for this is intended to be the research community. While LENR may be early on the path from lab bench to commercialization, it's never too early to start planning for how this will be used in the real world. And that way the field can focus efforts on addressing the most critical challenges and reducing the time to commercialization, which is important to me, both as someone who cares about climate change and as an investor with fiduciary duty. So with that, I think everybody has probably seen this picture before, right? What is a moonshot? You've seen this definition. This is Apollo 11, that mission to the moon. And one of the critical things about any of these type of efforts is that there's a high degree of risk involved. I think it's also important to point out that this was not a $3 million VC seed investment that made this happen. Apollo alone cost $355 million, and about $26 billion was spent on the Apollo program over the period from 1960 to 1973. That's unadjusted for inflation. So these are not small projects. Moonshots are not small projects. If we think about other transformative technologies, here are some other ones that people might call moonshots. Metal oxide semiconductor transistors. You can read more about them at the Computer History Museum. But they essentially enabled the personal computer. ARPANET, initially a DARPA project, ultimately led to the modern internet. The Human Genome Project, that international collaboration where we succeeded in sequencing the entire genome for the first time, gave us low-cost DNA sequencing. Many estimate that at hundreds of billions in economic output. The NASA COTS program, that was about an $800 million investment by the US government that brought down launch costs by over 10x. And then most recently, as Jeffrey mentioned, Operation Warp Speed, mRNA vaccines. To put some numbers to it, the US spent about 18 to 40 billion to support COVID-19 vaccine development. And if you compare that to in 2021, global sales of mRNA-based vaccines are going to be over 50 billion. And so that's just in 1 year alone. I think a lot of us have gotten boosted since then. So these are big efforts that often involve the government. And I think, since the 2000s, it seems like we are more effectively leveraging the private sector along with the public sector. You might even be able to convince yourself that the time required to achieve some of these has come down, which is pretty cool. And the last thing I'd point out on this slide is it's hard to imagine where an effort will finish at the start. I think there's a great quote from someone involved in early mRNA research that, if you'd asked them when they got started if it was going to work, the answer would have been a heck no, basically. So that's one reason why it's really important that we, don't give up and pursue really ambitious, risky endeavors like this. In a lot of these cases, the moonshot either created something entirely new or something that was absolutely better. They are transformative. This one here is a no-brainer. But that's not always the case, and that doesn't mean that every moonshot idea is worth pursuing to the end. Here's an example, how many millennials here, I'm grouping myself in there, I've heard of Cray supercomputers. These were the fastest supercomputers of their time in the late 1970s. They were so good, they sold over 100 of them. Woo, right? But they weren't what the market was demanding, which was low cost and accessibility. So they were eventually acquired by HP. Meanwhile, Apples are everywhere. Yeah, stupid phone here too. So when we think about what would a transformative LE&R technology look like, how would that work, right? To me, that's the biggest challenge facing the field. How do you transform an industry that's essentially a commodity? There will always be a next lowest cost option, and that's a big challenge for any new energy generation technology. So, as we go forward, I know there are a lot of priorities. There have been a lot of great talks on some of the research needs, and I really hope that we keep thinking about at a high level. What are the costs going to be? What is the range of kilograms of metal to megawatts that we might need? This question around cost is going to be my first question as an investor, right? So I've kind of tried to detail in here where the dotted line target that RPE has set is. It's really great to have some kind of a metric or something to run after, right? You can always adjust it in 10 years, up or down, whatever needs to happen. But I think it's really important to keep this in mind as we go forward. So we talked a little bit about moonshots. How are moonshots funded? And I think it helps to start by zooming out and looking across what type of capital is out there. I think most of the things that Jeffrey talked about would be here in that green circle, right? But initially, we're looking at things way up at the high end of the risk spectrum, right? And so zooming in on just that kind of blue part of the curve, if we think about what type of capital there is, there's actually a lot. There's a growing number of forms of capital willing to support really risky but impactful technologies. And thank goodness for these groups, right? These are some of the things or groups that have enabled smallpox eradication, the internet, everything else. So obviously you want to be on the top side of the red line. Luckily, there are sources of capital across this group. So if we just try to put some in different places and don't take this too seriously, don't get mad at me. This is an example, right? But you can think about where a technology starts being really, really high on the risk spectrum, very, very unclear on what the return spectrum is going to be. There are groups, right? Think about philanthropic capital as being there. You can think about, where does the government sit? How much risk are they willing to assume, right? Versus who might be willing to, who sees that line as a little bit lower and is able to move across it. So this is a weird graph in that, you're going to start way out on the right side, and the goal is to get above the line eventually and move down that curve. And from an investor's perspective, even if you are on that right side of that perceived risk return line, the more you can leverage non-dilutive capital, the better off you're going to be. So in thinking about what falls into different types of camps and what the roadmap might look like for something very early, here's some thoughts on just how groups like us in the deep tech investor space see risk, right? Starting with science risk, which is something that not a lot of VCs are going to want to take. There are exceptions, but as a whole, it's difficult to get over that hump. Moving into engineering risk, commercial risk kind of goes hand in hand with that, and eventually graduating to project risk or something that's effectively commercial, right? So if you think about what type of things fall under each of these categories, right? Science risk is when you're still asking yourself, will it work? Do we understand what's going on, right? And so at that stage, really you're looking at a lot of public sector dollars or philanthropic organizations, people who want to leave a legacy, people who want to help the world, people who don't need to be on the right side of that risk return line. I would say, Fusion is, depending on the group, moving more into the engineering risk side of things. I think there was an event I was at where we had a really fun argument about whether or not something was at a TRL 8 or a TRL lower than that, depending on repeatability, all that stuff. Right. And then moving on into engineering risk, there are things where we know it will work. The question is, when and how cheap will it be ultimately to be able to do this at scale, right? And so that's things like, in my mind, CO2 capture. We know how to do it. We just have to refine, get it cheaper. Moving up a level into commercial risk, there's some things where we know they'll work. We even know how much they're going to cost. The problem is, when you think back to that Lazard estimate of what are all the electricity costs out there, some things don't pencil right now necessarily. So in the US, we're struggling to make nuclear fission pencil. That may not be true for other parts of the world. And when I say nuclear fission, I mean some of the advanced reactor types. Wastewater treatment is another area where water is priced really weirdly in the US, right? We know there are better technologies we could use. They haven't been scaled yet. There's commercial risk there. And then in the project risk, and eventually getting the things that are financeable. That's still, it matters what the ROI is. That's something that makes me really concerned, thinking about the future interest rate environment. Like, what does that do to wind and solar projects? If that brings down, if bonds go up, what does that do to other things within the system? So it's important to kind of think about the interplay and how all of these components work together. So jumping into tips for raising private capital. This is a framework that we kind of like to use, or I like to use. I think it's easy to understand. There are two ways that you can push investors towards a yes, right? You can make progress, you can hit milestones, that's on that x-axis, or you can build credibility. And the combination of those two things is really what's going to get somebody to accept the level of risk that you're presenting. So if you go all the way, maybe high on credibility, low on progress, this would be Elon Musk decides to start another company, maybe, right? And everyone's like, oh yeah, he can start companies, great, we're going. On the other end of this, let's say you have a fully working perpetual motion machine, and it's working and it's there, and nobody has even heard your name before. Well, now you've shown enough progress that this will work. So ways to boost your credibility, obviously, peer-reviewed publications in breakthrough science, tough tech, whatever. Those are critical. Reputation within the field, third-party validation, all the types of things that you would expect. Looking at milestones again, it's so helpful to have well-defined key metrics that you can point to and show, hey, this is where we were last year. This is where we are this year. This is where we need to be for commercial, basically. That's super helpful. Bringing on partners, building prototypes, letters of interest from companies, all of those are great things. One more comment, just because you can't say it enough. A rising tide lifts all boats. One thing that we've seen be really effective in other industries is when the industry works together and doesn't shoot each other down and celebrates the wins that everybody has. Fusion Industry Association has done a great job of this, and that just helps build credibility for all. So lastly, hopefully soon we'll get to the point where there are LENR companies coming to pitch us. Just some things to keep in mind. A is knowing who you're pitching to. Like, do you have to tell them about the energy challenges ahead and that we're going to need more energy, or do they already know that and you're just trying to convince them that, hey, look, this experiment has now shown that this is a real thing and we're ready to go, right? Do they already accept your thesis? The next is, does your financial model fit the investor's return threshold? And early on, that could just be, this is important for the world. We agree? Okay, great. With non-impact or non-ESG investors, they might be expecting to see a certain return on a certain timeline in 5 years and 10 years and some number of years. And so knowing what they're expecting and making sure that that is made clear is pretty critical to getting to a yes. Being able to clearly communicate the coming milestones is critically important, right? Everybody thinks in terms of funding rounds. So is this funding round going to be enough to get you to a place where somebody's going to be excited about putting more money in this? So you've taken more risk off the table. You've gone from science to engineering risk, or maybe now you're ready to access project finance. And then lastly, like, do you have the right team on board to execute and achieve these milestones? And that basically is a standard pitch deck, right? But you'd be surprised how many times some of these components are missing. And so with that, I think I'm still doing okay on time. Just to emphasize, why myself and our firm are interested in things like this, right? And I know a lot of these have been gone over already today. We do see the pace of technical progress accelerating. Things that were crazy 10 years ago are no longer crazy at a high level. Specifically getting down into some of the advances in related fields, in advanced computing, in nanotechnology, in materials, in quantum technologies. I've seen some muon technologies that are interesting. There's a lot of things that remove and lower barriers across kind of this space. So we're like, oh, what's going on over here, right? Learnings from manufacturing, right? Electrochemical technologies. We've seen a huge boom in electrolyzer companies. We've seen a lot of innovation in nuclear science and engineering, including within the broader fusion space. Semiconductor manufacturing, obviously doing really interesting things at very small scales. And this all makes it possible for us to imagine, hey, maybe you could make some sort of a device that would actually meet some of those energy cost targets. Diagnostics improving, that one's huge, right? In the fusion space, we've seen a lot of just really great applications of technology to do much better analytics and diagnostics. Also, just high level looking, and this kind of goes back to the pace of technical progress accelerating, like the learning curves for wind, for solar, for lithium-ion batteries. We've seen that for things that aren't super complex, highly integrated systems, those curves can be so rapid, like so much, more than you would have expected 20 to 30 years ago. So that, I think, combined with some of the unique features of LE&R, make us very, very curious. That said, the things that I would want to see to have a serious conversation is establishing a firm scientific basis. I know there's a lot that goes under some of that. We heard about it in Scott's talk earlier today and in several of the other ones. Doing the high level engineering cost estimate calculation on this to come up with some sort of hey, here's a system size or a cost or a sensitivity analysis, at least for something. And maybe it's a different size later. Got to start somewhere. Assessing the use cases and market sizes. So we spend a lot of time thinking about what is applicable globally, what is applicable in North America, what is applicable in areas where the sun doesn't shine as much, the wind doesn't blow as much. This all affects, it's easy to say energy is a $40 trillion market, right? But how much of that is actually accessible? And then determining the key milestones and value inflection points to get there. So we're excited to start having these conversations. I have no idea what this conference is going to look like in 10 years, maybe 20, 15 years. And that's one of the most exciting things. I think there's a silly quote from the old chairman of IBM that maybe there's a market for 5 computers, right? We don't know what would be possible if certain things are unlocked. So with that, I will say thank you again for having me, and thanks everybody.